Okay, for example 9, a compound fraction is in the form of a fraction, looks like this, and has one or more fractions in the numerator and or denominator. Okay, it doesn't have to have, this one has everything's a fraction, right? So taking a look at this, this is a fraction, and this is a fraction, and this is a fraction. Everything's a fraction inside the fraction. It doesn't have to be like that. It could be just as simple as 1 plus 2 over x over 3. That's a compound fraction also. It has one or more fractions in the numerator or denominator. So any fraction looking at that has fractions living in it is a compound fraction. This is just one I just invented. I'm going to throw it away because it's not part of the problem. I just want you to know not every little piece has to be a fraction to be considered this thing. There are different ways of doing these problems. Okay, the best way I've ever learned, the most efficient way, is to look at the entire problem as a whole, okay, and really identify those things that are fractions. So here's my main fraction bar. I choose the one that's the longest. Okay, and then identify within the numerator and the denominator all the fractions you're looking at. So 1 over x is a fraction, put it in parentheses. 2 over x plus 1, put it in parentheses. 1 over y, put it in parentheses. We want to identify the least common denominator of every single fraction in the problem. Whatever that is, figure it out. Right? So the denominators currently are x, x plus 1, and y. Those are my current denominators. Do any of those denominators factor to something that can be broken down? I don't see any powers at all, right? So this would be the one I think maybe could factor, but no powers in it, so that doesn't factor. X and y are prime. I can't break down x or y into a couple things that make them, right? So these are all prime and factored as much as possible. So the least common denominator, least common multiple of the denominators is x times y times x plus 1. You want to locate that thing, the least common denominator of all the fractions. Okay. And it goes like this. And I actually need some room to write some stuff, so I'm going to write it down here, only because I don't have room up there. So 1 over x, I'm going to leave a little bit of space here. And then 2 over x plus 1. And then I'm going to put 1 over y. So what we're going to do is whatever the least common denominator of all the fractions in the problem is, which is this guy here, we're simply going to multiply each piece, this piece, this piece, and this piece, whether or not they're fractions or not. In this case, they're all fractions. That doesn't matter. If this said plus 7, I'd multiply that times it also. So every piece, so every term you're looking at. So if I look at this guy here, this is a term, this is a term, and this is a term. Every term is going to be multiplied by that thing. So times xy times x plus 1 times xy times x plus 1 times xy times x plus 1. Okay. Those terms that are fractions will reduce before you multiply. Those terms that aren't, just multiply. Again, here every term's a fraction, but again, they don't have to be fractions. Okay. The xy times x plus 1, every one of these things I'm multiplying is a numerator object being multiplied by a fraction. All right? So officially this is over 1, this is over 1, this is over 1. If there were 4 terms get multiplied by xy times x plus 1. The number of terms in the problem, every single object, so things separated by pluses on top, things separated by pluses and minuses on the bottom. There's 2 terms on top, 1 term on the bottom. That's all there is, so 3 multiplications happen. I'm going to reduce what reduces. So this x cancels this x. This x plus 1 cancels this x plus 1. This y cancels this y. Again, each and every one of those things is being multiplied by a fraction, so cancellation happens. If I had a non-fraction, I'll throw another one up here in a moment just to show you what a non-fraction structure looks like. We'll deal with an easy one just to see how to handle it. But cancel what cancels, and then multiply the leftovers. The leftovers are the numerators times the numerators. This is 1 now, because the x's cancel, left with 1 and 1, right? 1 times 1 is 1, that's no longer a fraction. So I end up with, for this whole term here, I've got 1 times y times x plus 1. For this whole term here, I have plus 2 times xy. For this whole term on the bottom, I've got 1 times x plus 1. And the final step of simplify is to distribute, get rid of those parentheses, combining the like terms that you see. So if I simplify the last step here, y times x, y times 1, x times x, x times 1, I'm going to end up with, on top, xy plus y plus 2xy. On the bottom, I'm going to get x squared plus x. That may very well be the end of the problem at this point, but then the last thing we look for is if there's any like terms, we've got to deal with that scenario. And you'll notice that xy and 2xy are like terms, right? xy is 1xy. We're adding it to 2xy. Both are positive, so we're going to get positive 3xy. Maybe we're going to get 3xy. Well, pretend it says 3xy plus y on top, and x squared plus x on the bottom. That doesn't show up. That's the best I can do. The board's against me. Wants me to fail and have bad videos. All right. So, and I did say I was going to show another problem like that. And now my board's not working. Let's see if I can get a new page. Maybe it'll work. Hey, it works on a new page. All right. So, suppose I have x plus 2 over x over 3 over y plus 4. Let's say we have that problem. Once again, that fits the description of compound fraction because we have a fraction. Here's our main fraction bar here. This is a fraction, this is a fraction. So we have fractions in the numerator and denominator. X and 4, of course, are not fractions. They don't count in our search for a common denominator. All I care about is a fraction. So you'll see here that the denominators are x and y. X and y are completely factored, so there's nothing we can do to make them any simpler or break them apart or anything. So the least common multiple is going to be x times y. I've got 4 terms here. This is going to be multiplied by xy. This is going to be multiplied by xy. We'll put that over 1. xy over 1 and xy. You'll notice the fraction pieces. Probably the part where I got in trouble earlier, we'll see. The fraction pieces, I'm multiplying by a fraction structure, xy over 1. The non-fraction pieces, I'm just writing times xy. So, nothing cancels here because there's no fractions. xy times x is x squared y. X cancels x here. X cancels x here, so we're left with 2y times 1, so plus 2y. Y cancels y here, so we're left with 3 times x. And nothing cancels here, there's no fraction, so it's going to be plus 4xy. Okay, so when non-fractions are present, you still do the same process. The fraction pieces have cancellation happening, the non-fraction pieces are just straight multiplication. All pieces must be multiplied by the same thing. If this happened to say minus instead of plus, that'd say minus instead of plus, so the signs are what they should be based on the products. All right, so those are the types of things that could show up on these problems. But that's the easiest and most efficient way to deal with a compound fraction. find the common denominator of all the fractions, multiply each and every term by that, simplify as much as possible.